Hello everyone, now we have to discuss the next concept of power relations, that is types of power relations. Those are active power, reactive power and apparent power followed by complex power. So, first we have to discuss active power. Active power. So, what is this active power? So, the actual power, the power which is actually generated, transmitted or consumed or absorbed by the load is nothing but active power. The power is actually generated, transmitted or utilized or absorbed by the load is called active power. So, the power which is generated, transmitted or absorbed by the load in the power system is nothing but active power. The only power which is responsible for the energy transfer is nothing but active power. Actually, see the sentence, actual means the actual power in the power system which is responsible for the energy transfer. As we studied earlier, the power which is responsible for the energy transfer is nothing but average power. Then, is there any difference between average power and active power? Obviously, there is no difference between average and active power. Both are same. Okay? This is the first point. Second one, as we studied earlier, the power which is responsible or capable for energy conversion is what? Average power. We all know that the average power is nothing but RMS power, right? So, the actual power which is utilized by the load is nothing but active power, and the power which is responsible for the energy transfer is nothing but average power. Obviously, both are same. Therefore, there is no difference between average and active power. Both are similar. Both are similar in nature. Right. So, next important point, it is the actual outcome of the system which can runs the load. That is the meaning, right? The power which can be utilized by the load is nothing but active power. Means what? It is the actual outcome of the system which can runs the load. That is, it represents the useful work. It represents the useful work. This is very important. It represents the useful work which is expected by the load, which represents what? Useful work which is expected by the load to perform to perform what? Real work. To perform real work. Okay, means simple words we have to say the power which is utilized by the load to perform real work is nothing but active power. Therefore this power is also called as real power, that is true power. So, concluded one point, active power which is equals to average power which is equals to RMS power which is equals to real power which is equals to true power. We have so many names. For one power we have so many names. That is what? Active power, which is nothing but average power, which is nothing but RMS power, which is nothing but real power, true power. But the function of that power is nothing but what? It is utilized by the load to perform real work. Means it is useful work. Means it is useful power. In entire power system, the useful power is nothing but active power. That is, in entire power system, the useful power is only active power. That is it. Therefore, we all know that P active is nothing but what? VRMS into IRMS into, this is the formula for average power. Both are equal. That is why P active is equals to RMS into IRMS into cos phi. Right? Measured in watts, kilowatts or megawatts. This is about active power. Next we will discuss reactive power. Reactive power, that is Q. For active power the representation is what? P. For reactive power the representation is what? Q. Then what is reactive power? See the name, reactive. We have reactants, right? The name we have reactants means what? The name itself consists of reactive elements. That is why we have the name reactants. Therefore, the power which is associated with the reactive elements is nothing but reactive power, right? The power which is associated with reactive elements L and C is called reactive power. That is it. One more important point, it flows in both the directions, that is back and forth. So, this reactive power flows in both the direction in the system, whether it is back or forth, depends upon the type of load. Depends upon the type of load. So, what is the statement, sir? We do not understand. So, reactive power flows in either direction, whether it is back or forth, depends upon the load. We have different types of load: series RL load, series RC load. That is nothing but series connection of R and L elements, is nothing but load only. From now onwards, we have to discuss the entire concept with respect to load. So, with respect to RL load, it is flows in one direction. With respect to RC load, it flows in another direction. We will discuss in detail. Here I am providing the basic concepts of active, reactive, apparent power. Later we will discuss in-depth analysis of these powers. So, wait for some time. From maybe in the next lecture, I will provide the entire in-depth concept of these powers. We will discuss in-depth concept with respect to different types of loads. That is very important observation. Okay. So, it flows in both the direction, that is back and forth, depends upon the type of load. Clear? It is not useful in any work in entire power system. It is not useful in any work in entire power system. Therefore, this power is also called as wattless power. The other name of this power is nothing but wattless power. Why? This is not useful power, means this is not useful power. That is why it can be named as wattless power. Then why we need this reactive power, sir? Then this the name itself wattless power, then why we need this reactive power in the entire power system? There is a reason for that. Whereas it is required to produce electric and magnetic field for the operation of electric capacitor and inductor. That is only. This is the reason why we are using reactive power in the entire power system. Okay. This is not useful power, but because of this reason we are using reactive power in the entire power system, whereas it is required to produce electric and magnetic field for the operation of capacitor and inductor. That is only. Okay. Therefore, it is represented as Q, which is nothing but Vrms Irms into sin phi. This is the formula for reactive power. Okay. Measured in VAR or kVAR or MVAR, that is volt ampere reactive. Volt ampere reactive. This is about reactive power. Next we will discuss apparent power. What is represented as S. Then what is apparent power? Which is nothing but combination of active and reactive powers. active and reactive power, or we can say product of RMS values of voltage and current, product of RMS values of voltage and current, that is S is equals to into IRMS. This is the apparent power. So, which is nothing but combination of active and reactive powers, or we can say the product of RMS values of voltage and current. Next, measured in volt ampere or kilovolt ampere or mega volt ampere. Volt ampere. This is about apparent power. Next, we will discuss complex power. It is denoted with S only. Okay. Complex power. We all know that P is equals to what? ERMS, IRMS, cos phi. Q is equals to VRMS, IRMS, sin phi, and S is equals to product of VRMS and IRMS only, right? Okay, this is about PQS. Then let us consider P e power j theta. Okay, like that current is equals to I e power j theta plus phi. It is which is equals to what? VRMS at an angle theta, IRMS at an angle theta plus phi, means current leads voltage by some angle, see theta plus phi, right? So, from this complex power S is equals to VI conjugate. This is very important. So, here we are denoted with what? S. What is S? VRMS into IRMS, that is only product of voltage and current, but here you are providing voltage into conjugate of current. Why you are providing conjugate of current? I will explain the reason later. After the derivation, I will explain the reason. Okay. So, from this V is equals to what? V into e power j theta, that is V into e power j theta, which is equals to P cos theta plus j sin theta, right? Like that I conjugate, that is I e power theta, this is I, okay, which is equals to what? Sorry, I into cos of theta plus phi plus j sin theta plus phi. Therefore, I conjugate is nothing but I into cos of theta plus phi minus j sin theta plus phi. That is it. This is about I conjugate. Therefore, I into e power minus j theta plus phi, right? Minus j theta plus phi. So, cos of negative angle is always positive, that is why here minus j sin theta plus phi. Clear? This is I conjugate. Therefore, complex power S is equals to what? V from this S is equals to what is the value of V? V e power j theta into I e power minus j theta plus phi. Therefore, S is equals to V I e power j theta from this e power minus j theta into e power minus j phi, right. So, this one gets cancelled. Therefore, S is equals to V I e power minus j phi, V I e power minus j phi, which is equals to so from this V into I cos of minus phi means what? Always phi minus j sin phi. So, S is equals to V I cos phi minus j V I sin phi. Then what is V I cos phi? See, these are nothing but RMS quantities. These are nothing but RMS quantities only. Okay, VRMS. Like that, this is also RMS quantities. Okay. Therefore, it is equals to P minus J Q, right. So, from this S is equals to P minus J Q. See, here the current is leading quantity, voltage is lagging quantity. Therefore, this is the complex power, for capacitive load. Means what? RC circuit, means RC circuit, complex power for capacitive load. See, for example, if you have any confusion, just consider this example. For RC circuits, for example, consider RC, any RC circuit, whether it is series RC, parallel RC, that is, what is the impedance? R minus J XC, right? This is series RC circuit. Series RC circuit. What is the impedance there? Z is equals to R minus J XC. If we multiply it with what? I into R minus J I into XC. Clear? I into Z is nothing but what? Voltage. Voltage across resistor minus voltage across capacitor. Clear? Again, I square into Z, I square into R minus I square into XC. Then tell me which one is active power, which say this is what? I square R is nothing but power only. I square XC, power only. I square Z, total power in the circuit. This is nothing but what? S. This is what? P. This is what? Q. So, from this, tell me S is equals to P minus J Q. S is equals to P minus J Q. Then tell me, this both are equal or not? Both are equal. See, if we have any confusion, S, we got S is equals to P minus J Q. This is capacitive load, that is capacitive circuit. That is why consider any capacitive circuit, that is here I am considering series RC circuit. For that series RC circuit, what is the impedance? R minus JXC, right? So, we are multiplying it with what? I. Again, we are multiplying with what? I. We got I square Z is equals to I square R minus J I square XC. We all know that I square R is nothing but what? Power. I square XC is nothing but what? Reactive power. I square Z is nothing but what? Total power in the circuit, that is apparent power. So, from this S is equals to P minus J Q. Satisfied? That is why here I am considering conjugate. That is why we are considering conjugate. If we are not considering any conjugate of this current, we are going to get P plus JQ. Can we get P plus JQ for capacitive load? Obviously not. If we are not considering any conjugate here. We are going to get the complex power as P plus jQ for capacitive load, P minus jQ for inductive load. Therefore, there is a mismatching of circuits. That is why for complex power we are considering conjugate of current. What we have got? For example, that is case 1. It is V is equals to V e power j theta, I is equals to I e power j theta plus phi. Okay. These are nothing but RMS values. There is no need of providing RMS. Here we are providing capital letters. That is why those are nothing but RMS only. Therefore, for this S is equals to P minus jQ, right? Complex power for capacitive load. Therefore, this Q is nothing but what? Reactive power, that is capacitive reactive power. Clear? Then we will discuss case 2. That is here again P into e power j theta, coming current I into e power j theta minus phi. Minus phi means what? Lagging. Here we are considered plus phi, leading. Current leads voltage by some angle. That is why complex for capacitive load. Clear? That is P minus jQ. Next, j into theta minus phi. Minus phi means what? Lagging. Current lags voltage by some angle. Therefore, for this complex power is equals to what? V I conjugate, right? Therefore, I conjugate from this is what? I into e power minus j theta minus phi. That is it. Clear? Therefore, V into I conjugate is what? V is what? V e power j theta, like that. I into e power minus j into theta minus phi. Therefore, V I e power j theta e power minus j theta into e power j phi. Clear? See, these two are gets cancelled. Therefore, we have V I e power j phi. So, V I cos phi plus j V I sin phi, which is nothing but what? P plus j Q. This is complex power for inductive load. Now we have clear idea, right? Again, if you have any confusion, consider any L load, that is series. Here I am considering series RL load. For that, impedance is what? R plus J XL, right? We have this R plus J XL. Then multiply with current I into R plus J I XL. Again multiply with current I square into Z, I square into R plus J into I square into XL. Then tell me, I square into Z is nothing but what? S, which is equals to, this is P, this is equals to what? Q, which is equals to what? P plus JQ. Clear? Satisfied? That is why we are considering conjugate of this current. This is about complex power per capacitive inductive load, where key point plus Q means what? Inductive reactive power, minus Q capacitive these signs are very important, plus Q minus Q. Plus Q means what? Inductive reactive power. Like that, this minus Q is for capacitive reactive power. This is about complex power.